Hello, everybody, and welcome to our talk today. My name's Tasha, and I'm a 3D technology evangelist working from the Esri R&D Center in Zurich. I'm joined today by my colleagues Stefan Arizona, who works together with me in Zurich, and Rex Hansen, who works from our headquarters in Redlands. And we're looking forward to talking to you today about extended reality, or XR, with ArcGIS. First up, let's start with an overview of the different XR offerings we have within the ArcGIS universe and look into some terminology as well so that we can all be on the same page before we move into a bit more of a deep dive of our tech. Here's a diagram essentially showcasing all the ways that we can bring our GIS or CAD or BIM data into an XR context. You'll see this diagram pop up a few times today, and we'll go into each one of these workflows in more detail at some stage during this presentation. The first term I'd like to look at today is VR, or virtual reality, which is really all about being there. This is typically done by using a VR HMD, which stands for head-mounted display. And what we're essentially doing is teleporting to another location in a virtual world. In general, you can view, move, and interact with this virtual world, often depending on the device inputs that are provided. Here's an example of a VR experience that provides different urban plans within a city. In this case, it's done using a mobile VR device, which allows you to go to different locations by selecting different viewpoints or different experiences. Here in this case, you can toggle between different scenarios to see the impact, like shadow casting, that this tall building might have on its surroundings. The next term I'd like to speak about is AR, which stands for augmented reality. AR is really all about interacting with the real world by overlaying virtual content. And this is generally done by using tablets, smartphones, or AR glasses. This video shows route guidance through one of our office buildings in Redlands using a smartphone. The user's geographic position in the real world is the starting point, and the office of interest is the destination. Once the name of the destination office is entered into the keyboard, the route is plotted out for the user by overlaying virtual content onto the real world. And you can see that this is interactive enough to allow the user to follow along in the physical world and use this virtual overlaid wayfinding to get them to their location. The third term today is mixed reality, also known as MR. MR is about fully immersing virtual content into the real world, and I guess it's really kind of like a next step in augmented reality. The way to view a mixed reality experience would be through some sort of headset like the Microsoft Hololens or the Magic Leap. Here's an example of virtual content with some holographic and some virtual geometry represented at world scale to view plans and structures in the field. This is a great way to see what would be built at full scale in this spot in the future. And the really great thing here is that you can view this live and on site whilst in the real world location. You can also incorporate things like hand gestures so that you can interact with the MR experience accordingly. Another common use case for mixed reality is, for example, here where you can stand on the street and see the different utilities that are below the street surface. Something that we're seeing often now is that all of these things come together and become something called extended reality, or XR for short. This is used to describe the full spectrum of VR, AR, and MR. And now, when you transition from the physical world to an extended reality experience, you can choose to supplement the real world with virtual content. So whether that's overlaying information onto the real world, in the case of AR, merging information into the real world, in the case of MR, or completely immersing yourself into a virtual world, in the case of VR. All right, so now that we're all on the same page with regards to our terminology, let's move on and talk a little bit about what positional tracking means for extended reality experiences. Primarily, different techniques for tracking hardware movements, for example, in headsets, is necessary to provide a natural response to physical movements. Inside-out tracking uses cameras or sensors on the HMD, and outside-in uses sensors placed in stationary locations around the device or around the camera. Outside-in can be a bit more difficult to maintain, and it can actually be quite restrictive, and sometimes it can even be more expensive. So therefore, inside out is usually the more preferred method, as it relies on sensors that are built into the device. And markerless tracking means that it doesn't require a physical object for initial calibration and relative surfaces to determine the position and the orientation to respond to our different movements. So it feels as natural as possible. With that being said, AR and MR devices can also leverage this technique to determine orientation, but marker-based tracking can provide the initial position in the real world, which is really important for AR and MR experiences. A marker could be something like a QR code, which is what we can see here in this picture, or it could also be something like a natural feature or objects that are recognizable and stationary that have a well-known predetermined geographic location. AR and MR devices can use these control points or spatial anchors, as they're also known, to provide a more accurate location. So of course, positional accuracy is extremely important in AR and MR to overlay or merge virtual content in the correct location. Luckily for us though, we can use other sensors and techniques to provide varying levels of accuracy. So that can range from GNSS to Wi-Fi to 5G beacons to RTK positioning. These all provide varying levels of accuracy and cost. So the goal here really is to find and use the appropriate level of accuracy needed to deliver a sustainable AR or MR experience at an affordable cost. Okay, great. So now let's take a look at the different XR devices that exist in the marketplace today. There are a significant number of XR devices that exist today at a varying price tag. All have different benefits and drawbacks, but the market is still pretty dynamic. So for example, there were a number of startups in the AR headset or mixed reality space that have since gone out of business, and the better financed and more integrated systems have prevailed. On the VR side, there used to be a clear segregation between premium and mobile systems, but now it's all pretty much starting to converge. So for example, Oculus or Facebook are discontinuing their Rift product line, which would fall under the premium VR category, and they're no longer building PC-only hardware. So both premium and mobile VR have 6 degrees of freedom and inside-out markerless positioning, and mobile hardware is getting better and better, with dedicated chipsets, for example, to deliver better VR experiences. But it still is difficult to match the graphics capability and the computing power of VR systems that are tethered to a PC. I would like to highlight one exception here though, and this is a really great example of this convergence that I just mentioned. The Oculus Quest can function as a mobile VR device, but it can also be tethered to a computer to leverage the power of a PC for a more premium VR experience. Hand tracking is available here, but more control over various movements is available with physical controllers. The next special mention is the HoloLens 2 for mixed reality experiences. Microsoft made some impressive improvements to the HoloLens, and the HoloLens 2 has a much better field of view. It has integration with spatial anchors, and support for Unreal and Unity really opens up loads more opportunities in this space. So let's move on now to XR user interface concepts. The first one I'd like to talk about today is the tabletop or table scale UX concept. This one's pretty common within the XR space. In general, tabletop or table scale represents a virtual model of a real-world object. So this could be a landscape or a structure or some sort of scene, and this virtual representation would then fit on a tabletop. And the main benefit of a tabletop UX concept is that it's relatable. In the real world, we could easily also find ourselves looking at something on a physical table. Experiences like this are generally used for designing collaborative experiences. It's intuitive as it represents a small-scale model that in the past was often created from physical materials. So, for example, in urban planning, concepts are often made up of a physical wooden model on a table, which then is iterated over in a collaborative environment. And because this whole concept is relatable to the physical world, motion sickness is no longer a problem. Teleporting is a good technique to move between locations quickly in VR experiences. Sometimes these locations are predetermined, but they can also be less restrictive to enable a more dynamic discovery of an area. Really depends on the scenario and what your requirements are. And as motion sickness can be an issue in VR, teleporting is usually an ideal way to get around without triggering motion sickness in the user. Unfortunately, it can cause a loss in positional perspective and orientation because you don't really fully know where you're teleporting to in the grand scheme of things. So that's also something to consider when you're building out your VR experience. Interacting with a virtual environment comes with a couple of challenges. For example, how to provide the user with an appropriate level of control without requiring more hardware. Also, you'll need to think about whether your user is using, for example, a mobile device with some sort of pen or stylus versus just using their finger. Often this depends on how much precision is actually necessary. Controllers, for example, can provide fast and consistent interactive experiences, but they can also be quite complicated. There's a lot of buttons and things like that that the user needs to sort of navigate around. And comparatively, hand tracking doesn't require any external hardware, and it is more intuitive, but the UI concepts for this are still nowhere near being fully fleshed out. However, this area is improving quickly, so on that note, let's take a look at some of the work that Microsoft has done recently with regards to this.
Fully articulated hand tracking. And as I move my hands around, the HoloLens 2 is actually calibrating to my unique hand size. Look at the way that the hologram is responding to my hand, almost inviting me to touch it. And in fact, I can just grab this corner to resize it. Or I can rotate it, or move it. That's right. We are touching holograms. Now, it's a little big, so let me just use two hands here to make it smaller, and then rotate it so you can see. There we go. And then let me put it down here near spatial, maybe make it a bit smaller. Yeah, that's nice. Let me just call it over with my voice. Follow me. So let me just open up that start menu here, and then place the app, and then launch it. So now we're actually exiting my mixed reality home and going into an immersive experience. But notice that that browser that I had actually followed me in. We spent years exploring and refining interactions for HoloLens 2. And the playground is just a tiny sampling of the many prototypes that we built, tested, and learned from. The interaction that really took home the cake, though, was this pinch slider. The way that works is you just pinch it and move it wherever you want. And what we found was that people really like that tactile sensation of their fingers touching as they grabbed and then released. And across the board, for all interactions, the audio and visual feedback as you grab, move, and then release were all really critical for making this experience feel connected. I just love the way these move and the sounds they play when I press them.
So yeah, as you can see, there's a lot of great work being done on this front, and a lot of this will start to become more and more familiar as mixed reality experiences are adopted into other industries. Next up, let's talk about the opportunities that we have with ArcGIS in the XR space. So here we are back at this chart again. It gives us a great overview of the different products and the different solutions that can be built and delivered using ArcGIS technology, and how we can access and use our GIS, CAD, or BIM data in this context. On that note, I'd like to hand over to my colleague, Stefan.
Yeah, so hello, my name is Stefan, and I'm going to walk you through a few of the options that you have when you want to create VR experiences using our technology. In particular, I'm going to show you a few of the possibilities that involve ArcGIS CD Engine, the 3D CD design software. And as we've seen before, there's quite a big variety of different AR and VR devices. So depending which devices you want to use, you will also have to decide a little bit on the pathway that you will choose here. So first, we're going to look a little bit at the 360 VR. Then I will show how you can use VR experiences with premium VR devices. And I will also show a little bit how you can go completely custom for Unity or Unreal Engine. So first, to start with ArcGIS 360 VR. ArcGIS 360 VR is CD Engine's mobile VR viewer. It provides quick immersion into designs and lets users experience, for instance, view impact. So a question like, does the new building obstruct my view from the balcony? What you see here on the right-hand side, right? On top, the building is not there yet. You have a view into the landscape. On the lower image, there is a new building, and that would obstruct some of the view that you would get. The workflow with 360 VR is really, really easy. It doesn't require any programming or tweaking. It is also web-based for a wide range of platforms. It works on desktop, mobile, and for all major VR headsets. So a few details on the workflow that you see here. What you do in CD Engine basically is that you model your CD, you define your design, you create scenarios, that what you see on the bottom image on the right-hand side. You define a few views, what you see here on the right-hand side on the top image. You create a 3VR package containing 360-degree panoramas and metadata, and you share this to ArcGIS. In the viewer, and you will see this in a second in a video, you basically log into ArcGIS. You select the experience in the content browser and you explore the scenarios and the views in the experience. So let's go and have a look. So here you basically see the Oculus standard web browser that goes to the site of 360 VR. You go and choose one of your experiences that you exported before. It loads that from the internet, and as soon as it's done loading, you basically will already get into the scene. So you see here basically you have a set of different views. You can navigate around. So we start with a bird's eye view. There's quite a few views here, so we go a bit lower. So here we have a roof with solar panels. Here you would also have different scenario. As you might know, that's often a topic of discussion, you know, what should the roof types be? Do the roofs still look nicely if you have solar panels or not? Or do you prefer to have more like old school roofs without any solar panels? So here's another view with a train crossing, different options for street design, for instance, in this case. In the background, you also see these other viewpoints defined in 3D space, so these blue markers. You can actually also go and just choose them, select them directly, and then it takes you back to that view where we were in the beginning. So as you see, everything is super easy and straightforward to use. So let's move on to the CD Engine VR experience. The CD Engine VR experience is a bit more complex. It's also made for premium VR devices. It's a template for Unreal Engine, and I will show you a little bit how that works. So basically, you will use the CD Engine VR experience template to quickly transform your CD Engine projects into interactive VR experiences. So not just 360 degrees panoramas, but real geometry, where you can navigate around and interact with the geometry in the scene. It supports premium VR devices such as Oculus Rift, HTC Vive, HP Revert, and so on. You can immersively go into cities, scenarios, and collaboratively review plans and projects. So it also supports multiple users. And you also have access to the templates source code, so you can customize the experience to your own needs. So in this video, you see basically how the VR experience works. You start out in a virtual planning office. So you start at that table, you see different plans, you see scenarios. So that's a bit similar to what we had before. But you see here everything's animated. You can freely move around. You can go and rotate the table. You can pan, you can zoom, you can switch different scenarios again. You can also go and change the time. Yeah, because this is VR, of course, you can also just jump into the city by pointing at one of these blue figures there, selecting it, and you're in the city. And you can look around, you can navigate around, you can teleport. You can, of course, change the daylight again. You have different viewpoints to navigate around. Yeah, so as you see, this is a little bit a different world here. But there might be cases where you want to get rid of all of that and just want to go completely barebone with your game engine of choice. And we also offer help for that. And I'll show you a few options. So if you want to go from CD Engine to Unreal Engine or Unity or any other game engine with full flexibility, we basically provide optimized exporters that also scale to large models. So you can transfer your models to game engines accurately and efficiently. So then you can use Unreal, Unity, or another game engine to create use-specific experiences with the platform of your choice. There's two examples here on the right-hand side, street level and street design to show people possible scenarios of different streets. And then on the bottom, we have something like a digital twin with added metadata that is being presented to the users. So here you basically get an overview of how that works in terms of a workflow. So to start with, you would basically accumulate all your models and all your data within CD Engine. In the case of Unreal Engine, you would then use the CD Engine Datasmith importer, which is a custom export-import process for Unreal Engine, which helps you basically to get the data from CD Engine into Unreal Engine exactly in the way that you would expect it, and also in the way that the engine expects it. If you use the FBX workflow for Unity, it works actually quite similar. So here you see a few examples. This is a scene in Unreal Engine with a 24-hour cycle in a city. We have lighting, we have sunlight, you see all the shadows. So it gets dark again towards the end of the movie. Yeah, and here's another example where we use the photogrammetric pixel assets for the plants, for the bricks. You also see animations or animated features in this scene, like the smoke back there. This is something where game engines are really strong at, so you can use all these game engine features to create your experiences and your scenes. We also have a specialty here, so you might ask, yeah, well, why can we not bring CD Engine's procedural modeling technology into your game engine? And yes, you can, at least for Unreal Engine. We have an Unreal Engine plugin called Vitruvio, which allows you to model your buildings in CD Engine, so you can use your existing rules and assets. You can then import CD Engine rule packages into Unreal and generate buildings instantly, modify their appearance on the fly, and you can also visualize all these buildings in real time, because that's what the game engine is all about. So you get really great visual quality in the editor and at runtime. Vitruvio is available on GitHub and the Unreal Marketplace, and the link below. And here you see a short video of how quite a number of buildings are generated within Unreal Engine, so that happens really quite swiftly. And when you use that now using the cinematic camera and the sequencer in Unreal, you can create really, really nice animations and movie sequences. So here you will see how you can still building change during your entire workflow. Yeah, so that was my part that involves ArcGIS CD Engine. I will now hand over to Rex, who will go into details and show you the cool stuff you can do with the Maps SDKs and ArcGIS Runtime.
Thanks, Stefan. Next, I'd like to discuss a new product, the ArcGIS Maps SDKs, designed for direct real-time access to ArcGIS data, services, and analytics within a game engine. Before we dig into capabilities and the technology of the Maps SDKs, I'd like to provide a brief overview of why this is important. So over the past few years, we've seen a number of industries, enterprises, or businesses pursue their next generation of 3D GIS solutions. As these solutions apply to the real world, they need to leverage existing authoritative geospatial systems while taking advantage of new technologies to gather, store, and distribute geospatial information. Of course, Esri, as the global leader in this space, has provided and continues to deliver the systems to manage, maintain, and utilize geographic data, and is at the forefront of defining new standards and technology to efficiently gather, curate, and deliver high-fidelity geospatial information. These new 3D GIS solutions include client applications that target specific workflows that require photorealistic experiences powered by real-world data. They need to take advantage of high-end graphics capabilities on modern devices and utilize hardware designed specifically to support extended reality experiences like headsets to power AR and VR workflows. These applications need to be highly interactive, responsive, and intuitive. They need to be designed to be visually compelling, immersive, and as realistic as possible to increase engagement, improve understanding, and optimize the environment for making decisions. Operationally, they need to support modeling and evaluation of phenomena in the real world, simulating natural and human-oriented activities and the interaction between them in the past, present, and future. In addition, they need to quickly render dynamic, real-time geospatial content accessible in the office and in the field for rapid analysis and decision-making purposes. A number of industries have already embarked on this effort and are pursuing targeted solutions founded on game technology. This is more than just gamification of GI solutions, which is basically the use of game-style interaction patterns to drive and empower users of software. It's the use of game engines to build the next generation of 3D GIS clients and experiences on new devices with new expectations. These industries and solutions include AEC for urban planning, commissioning of new construction, evaluating work sites in the field like we've seen earlier in this presentation, in defense and public safety for collaborative battle planning situations, for real-time monitoring, awareness and threat detection, and obviously looking for immersive yet cost-effective training. In natural resources to manage oil and gas pipelines and facilities, plan mining efforts and monitor infrastructure. In utilities to model resource flows, evaluate impact, and visualize and manage assets while in the field. In transportation to capture and manage geospatial assets, plan for new infrastructure and model vehicle movement. And lastly, in education to help drive a greater understanding of the world around us. But first, for context, a brief background on why game engines are important and what type of benefits they provide. As game engines have targeted gaming experiences, it was essential that they deliver high-performance, premium rendering of content with fast and fluid interactions to meet and compete in the gaming space. The highly competitive nature of the gaming industry helped push game technology and associated content and hardware to the limits of their abilities. As such, years of development have been invested in successful game engine vendors to build out premium high-definition rendering pipelines to deliver simulated world experiences optimized for multiple platforms and form factors. Of course, to build a more immersive and compelling experience, game engines also invested heavily in systems and APIs to simulate the real-time interaction and movement of real life. The introduction of high-fidelity assets, physics engines, animation properties, atmospheric water, and other special effects has enabled some game engines to deliver beautiful, photorealistic, cutting-edge visuals that appear and operate nearly identical to the real world. Game engines also provide support for targeting a wide variety of desktop and mobile platforms and dedicated specialized hardware. So many of the next generation of 3D GIS solutions include business use of headsets dedicated to extended reality or AR/VR workflows, such as HoloLens, Oculus Quest, and Rift, and HTC Vive. Game engines are built to support the responsiveness, frame rates, and fidelity needed to power these experiences, these devices. And last but not least, successful game engine vendors have existing developer programs and communities, help doc, forums, and tutorials, and talented individuals and organizations that know the technology and are available to do the work. With that in mind, we're delivering the ArcGIS Maps SDK as a developer product that integrates with the two market-leading game engines, Unity and Epic's Unreal Engine. The ArcGIS Maps SDK for Unity and ArcGIS Maps SDK for Unreal Engine will be distributed as plugins and provide APIs to access ArcGIS services and local data. This work will be founded on support for local and global 3D experiences through a scene which provides the context to display and interact with geospatial data and honor real-world geographic coordinate space. And of course, these products will include world-class SDK resources, as is expected from Esri's developer products. So let's review what's available in the current beta release. Keep in mind, functionality delivered in the Maps SDKs for Unity and Unreal Engine is equal, while functionality and the capabilities of the editors and engines themselves may be different. So development in the Unity or Unreal editor is supported on Windows and Mac OS. And although Unity and Unreal Engine support developing apps for a variety of platforms, with the Maps SDK beta, you'll only be able to build apps that target Windows, Mac OS, Android, and iOS. A bit more detail and support for Windows. This includes 64-bit apps on desktops and 32 and 64-bit UWP apps, which means we'll support use on the first and second generation of HoloLens. The Maps SDKs also deliver a couple options for working with the plugins. Both include a UI to configure properties of the scene, set camera position, and add and modify layers. Both include an API for developers to deliver a solution code. We also integrate with Unreal Engine Blueprints, a visual scripting system. Both local and flat Earth experiences and global round Earth experiences are available. And data sources accessible by the plugins include a single elevation service for terrain. This means an image service hosting lurk-encoded tiles with elevation values. This includes ArcGIS Online World Elevation Services for terrain and bathymetry. Also, we'll support multiple raster tiled layers, which include cache map or image data for display from a service or a local tile package or TPK. Sources can include ArcGIS Online base maps with imagery, topography, or street data. To add to that, we'll support multiple 3D object or integrated mesh scene layers. These layers are founded on i3s, an open specification optimized for the delivery and use of 3D data. So 3D objects can include textured buildings and structures, while integrated mesh includes a triangular network to represent a continuous 3D surface, usually acquired by satellite or aerial imagery. They can be delivered as scene services or as local scene layer packages or SLPKs. It's also important to note that we do not support built-in access to feature sources such as ArcGIS feature services in the current beta. We will target support in a future release. However, starting with the first beta, we delivered a location component to integrate custom content, game objects, or actors within the scene established by the ArcGIS plugin. So as a developer, you can use this location component and craft a solution that retrieves or creates feature geometry and attributes and display and use in a scene. In fact, you can use this location component to bring in a wide variety of geospatial content to participate within the scene. So let's take a look at a demo. So here's a video that shows Adrian Mario, our lead developer for game engines, using Unity to build a GIS app and deploy it to a VR device. It shows how we'll integrate with the game engine developer user experience. It includes a scene, project objects, and the inspector to set or modify properties of these components, and of course the viewport. Now, of course, we could build an experience with scripts, code, and such. We could deliver a prefab or use a prefab to configure scene content without writing code. So we use the control, and we'll geocode a location near the Grand Canyon. We'll set a base map, provide some imagery for context. We'll put on another raster tiled layer to overlay on top of our base map to provide better context, in this case a geology map coming from the USGS. We'll give it a name. We'll add to the layer list. We'll also add a local raster tile package that includes a set of contours to provide more texture to the landscape. There we go. We'll change the transparency so it's partially transparent on both layers. Then, of course, one of the benefits of using a game engine is special effects. This includes adding sky and fog to provide a more realistic atmospheric experience. There we go. And then we can preview our developer environment or our developer experience at full screen, of course. But we can also do more than just that. We can target a VR headset for an immersive experience. So in this case, Adrian is going to deploy his application that's using real-world data to an Oculus Rift S and fully immerse himself in a VR experience with this real-world data and be able to navigate in and around the Grand Canyon. Very compelling, very impressive, very visually appealing. Being able to interact with this live and local ArcGIS data sources combined in this virtual experience as he navigates around the sky and the landscape. Great. So what's available today and what's our release timeline? So the ArcGIS Maps SDK for Game Engine's beta program is public and it's available to join and participate today. Once you join, you can download the Maps SDK for Unity or the Maps SDK for Unreal Engine. The plugins include samples to get you started. The beta site includes links to doc and a set of forums to provide feedback and interact with the community and actually our development team. As far as our release timeline goes, our first beta was released last October. Beta 2 was released earlier this year. So based on feedback from the community, we'll be formulating a release plan that results in a production release by the end of this year. So we invite you to join our beta program and start participating today. So the next and the last option I'd like to cover is the availability of AR capabilities in ArcGIS Runtime SDKs. Note that ArcGIS Runtime SDKs provide tooling and support for native application developers. Now, augmented reality with ArcGIS Runtime is available for production use today. We delivered this a little over a year ago and continue to enhance where and when we can. These AR capabilities are enabled for mobile platforms only, for iOS and Android devices. These capabilities are not available for VR or MR solutions. So the AR capabilities are delivered with Runtime SDKs that support iOS and Android, which means the Runtime SDKs for Android, iOS, Qt, and .NET. They are delivered as open source toolkits, so developers can work with different hardware capabilities and with the ARKit and ARCore capabilities built into iOS and Android. Now, AR capabilities in ArcGIS Runtime deliver a set of supported experiences and use cases. The first one is a flyover experience, which is really designed for educational scenarios. The navigation of the scene using the device orientation feels intuitive, it feels natural. Tabletop is great for design scenarios where you want to view digital landscape or small-scale model on a physical tabletop or surface. So you can still see the physical representation of the real world and be able to lock digital content to a physical surface, then interact with that digital model or landscape as if it existed in the real world. Also ideal for collaborative planning scenarios. The last one is world scale, and this is really designed for inspection or collection scenarios in the field. Basically an overlay of digital geospatial content on the physical world represented through a device camera at a 1-to-1 scale. Now, a good example of world-scale augmented reality was built during a hackathon by a set of our runtime developers. In this case, we're looking at a demonstration of that application that was built, and it shows real-time locations of aircraft being pulled from an FAA feed and updating a scene in ArcGIS Runtime. Now, ArcGIS Runtime knows where the phone is and the direction it's facing in the real world. As we move the device around, we can see the camera and the digital content in the scene are updated together for real-time interaction. And this pattern exhibited here actually makes it easy to build a variety of different AR experiences. Now, one example here is flyover mode. We can select a plane, and now the camera is locked to that plane's location. We can move the phone around from the plane's perspective. We can see Big Bear Lake, and as you pan up, you can see our location, the green X, in this case Redlands, and other airports in the area. And if we freeze the frame for a moment, a couple of other aircraft. Now, in the end, all we're doing is manipulating elements in the scene, really based on real-time FAA locations. Now, there are a number of challenges and considerations when building AR experiences. One challenge is the ability of the employee, contractor, staff member, the general public to understand and use AR effectively. Often best to use the crawl, walk, run approach, where introducing AR capabilities into an existing workflow is done incrementally and intuitively. But the pace depends on the audience receptiveness and perceived value, and also the complexity. The take-home here is pace yourself and pace your project to achieve a notable return on investment. Now, the most significant challenge to building and delivering a world-scale AR experience is maintaining an appropriate level of accuracy for the position and the orientation of a device. Now, ideally, the overlay of virtual from the scene camera and physical from the device camera content matches perfectly. As the device moves in the real world, the position and the orientation of cameras should remain in sync. In reality, limitations of devices and AR frameworks and differences in the precision and availability of positioning systems will usually require your AR workflows to include an initial calibration effort to improve overlay accuracy. Fortunately, the ArcGIS Runtime toolkits are open source, so you, as the developer, can enhance it to use one or a combination of techniques to drive the calibration experience and maintain position and orientation. For example, you can use a device's built-in GNSS or GPS to get an initial position, provide a UI to adjust the position of the virtual surface, and features to overlay those in the real world, and then use an AR framework like ARCore, ARKit to handle changes in relative position. AR samples included with the ArcGIS Runtime SDKs provide initial examples for calibration experiences to help you get started. And lastly, it's also important to consider the readiness of your geographic data for world-scale AR experiences. Since your geographic data needs to overlay the physical 3D world, its accuracy in the horizontal, or lat-long, and vertical elevation space is important. In some cases, the location of features may have been established using coarse grain workflows, where the elevation information was not included or was derived from a low-resolution elevation surface. The accuracy required in your geographic data may differ depending upon how it's used. For example, to find the general location of a gas meter on a large property may only require about 10-meter accuracy, whereas a solution to determine where it's safe to dig to avoid a subsurface gas pipeline may require centimeter level accuracy. In short, consider what is needed to achieve the appropriate level of positional accuracy for the device and your geographic data in any world-scale AR experience. And with that, please remember to provide your feedback for this session by clicking on the link below this video. And I'd like to thank you for joining us, and thank you for your interest in extended reality solutions with ArcGIS. And if you'd like, please sign up for the Esri XR newsletter at the link provided in this slide. Thank you. Great, thanks for attending the XR and ArcGIS session. We're going to go into a session of Q&A here and take a look at some of the questions that have been posed out in the Q&A out on our Slido site, so we can work through some of those questions and maybe get you some answers, or at least give you some direction and get some assistance in this space. So let's start working down the list. The first question that we have is, how can we tell if City Engine is included in our enterprise subscription?
Yeah, so
Taisha?
I guess
Yeah.
I'll take this one, right? That's a really good question. I actually had to look up a little bit on how that actually works, but I put a link underneath the question. So generally, it seems as though City Engine's included in the enterprise subscription or in the advanced enterprise subscription. And now the tricky bit, we here don't have access to know what exactly you've purchased. So you should be able to go to your customer service portal, and you should be able to see what sort of subscription, there we go, you've purchased, and then that would hopefully be able to clue you into whether or not City Engine's included in that. So I hope that helps. Otherwise, just post a reply.
Cool, thanks, Taisha. Next question is, when will dynamic map layers be supported? Now, by dynamic map layers, I'm assuming this is dynamic map service layers. So we listed a couple of products in this session, kind of run down the list. So the ArcGIS Runtime SDKs support dynamic map services today, and they can be used in an AR experience. The ArcGIS Maps SDKs do not support dynamic map services yet, but it is on the roadmap. And City Engine does not support dynamic map services today at this stage. We would be interested for the City Engine approach. From the City Engine perspective, we'd be interested in finding out more details about what, how you intend to use dynamic map services. So that'd be great. Feel free to reach out to the team, maybe reply here with more details as well. So great to hear about that. Next question is, which of these SDKs, and I'm assuming developer experience, would be best for modeling different vegetation types? So I'm assuming if you're looking at modeling, there's some sort of analytics here. The analytics itself would probably end up requiring some sort of attribute infusion or some workflow that would require maybe some geoprocessing here, some extraction from imagery or extraction from other data sources. That would probably be using another product such as Pro. But in preparation for that data, for being able to publish and use that data, you could then visualize that information fairly easily within any of the developer products that we listed here with the Maps SDKs or the Runtime SDKs. It is possible that you could use some sort of lighter weight modeling techniques actually on the client side, or maybe some display analytics here, so that you could take feature information or attribute information and then represent that within a visual experience, either with a game engine or with a developer experience through any of our developer platforms that we support with Runtime. So probably best at this stage to be able to build out with a professional experience on the back end, but then you could use a variety of our developer client APIs to be able to visualize that on the front end. Next question, can City Engine be used standalone without a game engine? Stefan, do you want to take a look at that?
Yeah, so I go for that. Yeah, so City Engine actually is a standalone modeling application. I posted the link as an answer in the question as well. If you go to the City Engine homepage, so you will get an impression how it looks like. So it's actually the opposite. City Engine doesn't have any integrated VR support. So if you want to use or create VR experiences with City Engine, or bring it to the game engine, you actually use, for instance, to Unreal Engine, you would use a DataSpef export and then re-import it into Unreal Engine to create an experience.
Great, cool. Thanks, Stefan. Another question, how do I learn more about developing with the Maps SDK? Well, in this session, we listed a URL you could go to join the public beta program. Beta program links off to or provides downloads for the products, as well as some getting started video and links off to our documentation. That's probably one way to start. Another one is tomorrow we have an introduction to the ArcGIS Maps SDK for both Unity and Unreal Engine at 11:30 Pacific time. So feel free to join us for that session. Next question is, where can I find resources for preparing imagery to be ready for CityEngine, ArcGIS Maps SDK, ArcGIS Runtime, for both orthophoto base maps and for street photos taken from cameras mounted on a vehicle? So I think there's a variety of ways to get imagery into those products. One is directly. Another one is being able to curate or prepare that imagery, whether it's being hosted through services that we make available as part of the ArcGIS system, or then generated as packages that you can use directly. I would say for each of those products, probably best to take a look at what the documentation provides for those products for preparing and curating that imagery for use within those products. So it could be product specific. I imagine that there's going to be some workflows that would require use of ArcGIS Pro in some capacity, or other applications that curate that imagery. Next question is, does the ArcGIS Maps SDK for iOS beta incorporate iOS AR Kit? It does not today. It could be used with iOS's AR Kit. We are looking at being able to build out, maybe a little bit later this year, a toolkit for the ArcGIS Maps SDK that provides better insights into working with AR experiences. So be looking for that later this year. Let's see here. Does CityEngine work with imagery? And Stefan, do you want to?
Yeah. So there's. I also asked back actually in the question. It depends a bit what kind of imagery you want to get into. So typically you can have base maps with imagery on top of it, and then as soon as you start modeling, you can also use imagery as for texturing. Of course, I wasn't exactly sure what the question was referring to, but all these different image types, of course, play into your modeling pipeline.
Great. Cool. Thanks, Stefan. I think one thing to note here is that our Ask Our Experts showcase, or expo, is available with for more detailed answers and conversations about some of these products as well. So feel free to go there after this session for more information. Next question is, can CityEngine be used without VR hardware, and where would you just be looking at it on a desktop or a laptop?
Yeah, so similar as the previous question. So actually, CityEngine is a standalone application which is made for the desktop. So you actually cannot use it with a VR headset. We get regular questions like that, but we think it's best to actually go to a game engine to have the best experience in terms of frame rates and visual quality, and that's the recommended workflow from us. So you do the modeling on your desktop, and then go to the game engine to create the VR experience that supports a headset.
Cool. Great. Next question, what's the best way to reduce the size of the APKs by optimization of code? Is there a workaround on custom libraries, for instance? I added a response there with a link to a document with our ArcGIS Runtime SDKs. If you're talking about working with ArcGIS Runtime, the Runtime core library includes most, if not all, most of the functionality in Runtime, and there's no way to break that apart. It's not modular. But there are other techniques that you can use as part of the developer environment of choice to be able to reduce the size of a package or an executable. So I'd encourage taking a look at those options. Where to provide feedback on the beta program, assuming this is the ArcGIS Maps SDK beta program. So if you enter the beta program, it's public. There is a feedback option to provide information on either bugs or features that you'd like to see. There's also a forum that's quite active out there to provide to submit questions and work with the community. Does the Maps SDK support Oculus Quest? Next question. Yes, actually it supports Oculus Quest in the context of both Unity and Unreal Engine support Oculus Quest as a target, as an output. There will be some challenges there with being able to manipulate the viewpoint actually on Oculus Quest in basically a VR scenario. So there's going to be a few challenges there that should get better in the near future. I encourage you to come to our session tomorrow to learn a bit more about what we plan to do with enhancements to geospatial positioning. Are there any plans on support for working with React VR for web-based VR experiences? There's no plans on the Maps SDK side or the Runtime SDK side. I'm not sure, Stefan, is there something you want to talk to about this on the CityEngine side?
Well, we got started with the 360 VR, which will be released shortly, which is not based on React VR, but it makes use of WebGL and WebXR. So basically, there's nothing that holds you back using, for instance, React VR and start to connect that to the JS API from where you can use stream data from ArcGIS online. So technically that should be possible, although I can't really tell about the details, and quite likely there will be some details. Yeah.
Okay. So work in progress, possibly.
Yes.
Maybe an opportunity there. Yeah, coming up.
Yeah.
Great. Next question, can you create an AR object programmatically given fabric points using the ArcGIS Maps SDK? So one thing to keep in mind with the ArcGIS Maps SDK is that it's designed to integrate with the game engine specifically. And so that we aren't responsible for the rendering pipeline. We're allowing the game engine, we're enabling the game engine to use geospatial data that we're delivering through the Maps SDK. So things that you can do within a game engine are still available, and the meshes and textures that are available, basically the objects that are part of the geospatial information that's being provided through the Maps SDK is available to you. So yes, in general, many of the things that you can do within a game engine that then interact with other objects and meshes that are delivered through the Maps SDK are possible, actually. So there's a wide range of capabilities there that's available as a developer who chooses to use a game engine. Are there any plans to incorporate ArcGIS realistic preset models as assets in the game engine SDKs? So in the Maps SDKs, we are looking at adding support for and enabling support for different symbology that's part of the ArcGIS system. We're looking at possibly adding that support through the incorporation or use of styles. We'll see how that goes. It's on the roadmap. It's a little bit further out, but we're going to need that at some point. So we are looking into this, and we plan to do so in the future. Can we ingest?
We're being told we're running out of time, Rex.
Are we? Okay.
Yeah. So maybe just so any of these questions. So the booth that we're in is called Smart Cities and Digital Twins. Just if you want to pop by there and ask other questions.
Gotcha. And I'd recommend coming to our Maps SDK tech session tomorrow. We can answer more questions there. Also, there's a native SDKs section within the Ask Our Experts showcase. We're available there too. Again, as well, if you're working with the Maps SDKs, you can join the beta program and you can ask questions in our forum. And our dev team is constantly watching the forums and providing answers as well. So another opportunity there too. So, but thanks guys for attending. Some great questions, great interest. Looking forward to working with you guys in the future. So thank you.
Thanks everybody.